Hello everybody and welcome to Statistically Speaking. Today we're gonna take a look at variance and standard deviation. And what is this? Well, they are measures of the amount of variation for a variable around its mean. So if we have a low variance and a low standard deviation, well, most values are gonna be around the mean. If we have a high variance and standard deviation, they're gonna be more varied around it. And that is a quick explanation of what it is. But what is the difference between variance and standard deviation? Well, the difference is quite simple. The variance is the standard deviation squared. That's it. So, why do we need both? Well, the standard deviation is often the easiest to get a grip of how much it varies, while the variance is, in most cases, the one we actually calculate. So we usually start with doing the variance, and then we take the square root of that number, and then we get the standard deviation. So then let's look at the different symbols that we usually would see with these. And in the first row we have the variance symbols, and at the second we have standard deviation. So we see here the first one. This is a Greek letter and is sigma. And the variance we have sigma squared. And standard deviation we have just sigma. So it's pretty easy to understand. If we have sigma and we square it, we get the variance. That's how it works mathematically. And then we also have s squared and just s. We usually use these when we give estimates for variance and standard deviation, but they can sometimes also denote the real population variance and standard deviation. And then we have with letters var x and vx or sdx. So standard deviation for x or variance for x. This Vx, I don't know how common that is, but it's usually the one that I personally use just because it's shorter to write. But both is fine. As long as you don't have two different meanings that could be V, you could totally use V. And now let's look at how would we calculate these. Well, this is what the variance is. The variance for x is the expected value of x minus the expected value of x squared. So you take this difference and you square it, and then take the expected value of that. And that is the variance of x. But this way of writing is often not the case we actually do in the end. We can simplify this. So if you bear with me, I'm gonna derive this so we get a more easier to actually calculate form. So the first thing we're gonna do is that we take away these parentheses. So we're gonna get expected value of. And if you know the quadratic formulas, you know how to do this. Otherwise, I recommend looking them up. So we have x squared minus 2x expected value of x plus expected value of x squared. And then end parentheses. If you want to make this even more obvious, you can put parentheses around this. It doesn't change anything, but if it's easier to understand that we take the square of the expected value of x, then you could totally do those parentheses, but they are not necessary. The next step we're gonna do is that we use the counting rules that we had in the last video when we talked about expected values, and use that to get individual expected values. So we will get expected value of x squared minus 2 expected value of x, expected value of x, and you might see, well, this is just expected value of x squared, So we could just do that. So we get squared. And then plus expected value of x squared. Well, we do get the expected value of expected value, but that is just the expected value. And from here we see we have expected value of x squared and expected value of x squared. So we can simplify this one step more. And we get expected value of x squared minus expected value of x squared. So please take note at what you're reading and not necessarily what I say, because it sounds the same. Expected value of x squared minus expected value of x squared. But this is the step we usually want to look at, because this is often more easy to calculate than this step. And it is the exact same thing. So in this, we know expected value of x. We know how to calculate this. If you're unsure, just look at my last video about the expected value. I will put it in the description. But this expected value of x squared might be harder. I do touch on it in that video, but just to clarify, how would expected value of x squared actually be calculated? Well, the expected value of x squared, we have two different scenarios. We can have a discrete situation or we can have a continuous situation. So we're going to look at both. And if we have a discrete, so we have the sum of xi times the probability for xi, but this case we change the xi to xi squared, and then parentheses, of course. So it's just that simple. You take the same formula, but you change the x to whatever is in here. But the probability will still be the same. It will still be the probability for x. And then let's say we have a continuous situation, so we can't use the sum. Well, in that case, we still do the same thing as we would the normal expected value. We take our integral from minus infinity to infinity of our x times f of x dx, but instead of x, we take x squared. And yeah, it's just that simple. Just change the x to whatever you have inside of here. And then let's look at some counting rules. So let's say that a and b, that are constants. They are not variables. And x and y are variables. They can vary. So the first one I already wrote down what it is. It is that the variance of x will always be larger or equal to 0. And now we're talking about the real variance. When you estimate, depending on situation and formula, you might get negative, but that is very rare. You will, in most cases, with most formulas, always get positive. And this fact is why we want to calculate the variance before the standard deviation. Because the variance, if you looked closely enough, you see that we often have squares. And if we square a negative number, it will become positive. And that is the reason why we want to have them positive, because if it varies, it doesn't matter which way it varies, it will still be a positive variation. And then let's look if we have a variance of a constant. Okay, we have a constant. How much do we expect that to vary? Well, we don't. The constant will always be the constant. So the variation of a constant will be 0. And then let's have the variance of x plus a constant. Well, we will have the variance of x, because the constant will be 0, so we will just have the variance of x. In this case then, the variance of constant times x. Well, this will be the constant squared times the variance of x. And reasons for this, we can always derive and all that, but I'm not gonna do this in this video. But there are reasons why this constant will be squared. And then we have two different scenarios here, where we have constant times x plus constant times y, and constant x minus constant y. So, what is the difference between plus and minus in this case? Well, the first step we know, we have that just over here. So we have the constant squared times the variance of x, and then we will have plus b squared variance of y, and then we have one more thing we need to take into consideration, and that is plus 2ab covariance of x, y. And we can't see everything, so I will just push it a little there. There we go. Now, what is covariance? Well, covariance is something we use to calculate the correlation, and the correlation is the linear relationship between x and y. But we won't talk about those today, and I won't show how you calculate the covariance in this video. You can check that on your own, and I will also make a video about that. But one thing that is good to know is that if x and y are independent, so that they don't do anything to each other, say we throw a dice and we flip a coin, what one will get won't affect what the other will get. And in that case, when we have a situation like that, we can just take away that. So you don't have to worry about that. But in general cases, when they are dependent in some way, we need to have that there. So let's look at the next here. What will happen when we have minus? Well, the first thing will still be the same. And we will have plus here again. B squared variance of y. And the next term here, that will be minus EB covariance of x, y. So we see that these are very similar, it's just plus or minus depending on if it's plus or minus in here. But I want to look at one special little case when we have something like this. So let's say we have this situation, we have x and y are independent, and we want to know the variance of x minus y. What many people often do when they are not used to calculating with variance is that they will just take variance of x minus variance of y, which is wrong. That is not the right way. Because we can think of this as that we have 1x minus 1y, and we can also think of this as plus minus 1y. So what will this then be? Well, we will have 1 squared variance of x, and we will have plus minus 1 squared variance of y. And 1 squared will just be 1, and we don't have to write that down, so we will get variance of x. Plus minus 1 squared will be 1, so we don't have to write that down, and we get variance of y. So we'll see here then that if we have variance of x minus y, will be variance of x plus variance of y. Now, know that this is an independent case. If we have a dependence, then we will have to take that minus 2ab covariance xy. But in an independent case, it's easy to forget that this will become this. So I just wanted to remind that that is how it works. But now we talked a lot about the variance of x. Then how do we do the standard deviation? We haven't really talked much about that. I just mentioned it. And, well, it's quite simple. As soon as you have the variance of x that you have calculated finished, or you just know the whole formula, what you can do to get the standard deviation is that you take the square root of the variance of x. Please note though that pretty much all of the calculations need to be done in the variance. And then you take the square root of every calculation together, so that you don't think that you can take, okay, we take the square root of that plus the square root of that, when in reality you need to plus them together as the variance and then take the square root of that result. So I would always recommend do the variance finished first and then take the square root to get the standard deviation. So that was some explanation about variance and standard deviation. I did not explain how you do when you don't know the true values and you need to estimate it, but I feel like this video is long enough as it is, so I will make a separate video about how you estimate the variance, and then in extension, how you estimate the standard deviation. So there will be a separate video for estimation of variance and standard deviation.